Hi guys, welcome back to this channel. In this video we're going to be looking at the topic data storage. Now let's look at storage devices. So storage is one of the most essential function of a computer. Every computer, every device needs to store data, whether it is permanent or storing data temporarily. Every device needs to be able to store data. So when we talk about computer storage devices, we mean that they are hardware. They are the type of hardware that is used for storing, porting, or extracting data files and objects. And that includes internal memory, which we can call a primary memory storage, and also external devices that can be removed or connected when needed. So throughout this topic, we'll explore primary memory storage and secondary memory storage and even offline storage. We'll look at all these devices, how they work. Now, here is an illustration showing various memory and storage devices. You can see examples like um, the primary storage, which is RAM and ROM. Okay, we have example of internal secondary storage, HDD, SSD, and then we also have examples DVD, Blu-ray, USB, removable hard disks. So these are external secondary storage devices. Each one serves a different purpose. Some are for fast temporary storage, while others are for long-term data storage. And as we go through this lesson, you'll be able to categorize them and understand which one are best for each task. Now let's look at a summary of the difference between primary and secondary storage. So this primary storage includes storage like RAM, ROM, and this storage are directly addressable by the CPU, meaning that if they need to obtain data, the system when system is performing an operation and it needs to obtain data, it just goes straight to the storage to obtain the data. But for secondary storage, it is not directly addressable, meaning that when an operation is being performed, this is the secondary storage, let's say HDD or SSD, and then this is the primary storage, let's say RAM. So when the computer wants to perform an operation, data is moved from SSD to RAM. So it is not directly addressable by the CPU. So when the system needs to get data, the data needs to move to RAM first before it can be moved to the register when performing operation. Okay, so examples of primary storage are RAM, ROM, cache memory. Then secondary storage are non-volatile devices, meaning that these devices do not lose data when the computer shuts down. So they can be external and they can be internal. And examples of them are HDD, SSD, DVD, memory stick, and Blu-ray disc. Now let's begin with primary memory storage. So this is a computer memory storage that can be directly accessed from the CPU. So, and this includes both RAM and ROM. So the primary memory allows the CPU to access applications and services temporarily stored in the memory location. So primary storage is a fast storage, and it is where your active applications and data are temporarily kept while you are using them. So examples of primary storage: RAM and then ROM. And then examples of RAM, we have static RAM and then we have dynamic RAM. Now let's look at the primary storage one by one. So we have RAM. So when you open an application, it is loaded from your hard drive into the RAM because RAM is much more faster to access. So access time to load data in RAM is much more faster than when it is in the secondary or offline device. So what are the features of RAM? Of course, RAM means random access memory. So what are the features? It can be written to or read from, meaning that data can be stored and then data can be taken from the storage. And data can be changed by the user or the computer. Then it is used to store data files and part of an application or part of the operating system currently in use. So when you need to open an app, this app is loaded from your hard disk drive into the RAM, so which is much more faster to access. Then it is volatile, meaning that when the computer powers off, then the data will be lost. Everything in the memory will be lost. And then the larger the size of RAM, then the faster the computer will operate. Now, we'll understand this better when it comes to virtual memory. Why is it that when the RAM is much more larger? So when the RAM is much more larger, it means that there's no need for the computer to use another storage. Let's say the space of RAM can only fit in, let's say three data, and the computer needs to make use of four data. So meaning that this fourth data has to be stored in a virtual memory, maybe SSD or HDD. So because of that, it will take time for this data to now be loaded into RAM. So, but if you have a bigger RAM size, then there's no need for the computer to make use of the virtual memory. Now, let's look at the two types of primary storage. So there are currently two types: the dynamic RAM and the static RAM. First, let's look at the dynamic RAM. So inside a dynamic RAM, there are millions of capacitor and transistor. So in the dynamic RAM, there is a chip that will contain millions of transistors and capacitors. Now, what is the function of each part? So the function of the capacitor is to hold the data, the bits of information in the form of zeros and one. So each bit of the data is stored in a capacitor, while the transistor acts like a switch that allows the chip to control circuitry or to read the capacitor or change the capacitor's value. So it acts like a switch that is used to read or change the value that is stored in the storage. Now, because capacitor they leak charges, so dynamic RAM needs to be refreshed every few milliseconds. They need to be refreshed every few milliseconds. Otherwise, it will lose its value. So this is dynamic RAM. Now let's look at static RAM. So unlike dynamic RAM, static RAM does not need to be constantly refreshed because it uses flip-flops which hold each bit of memory. So the flip-flops is used to store bits and they are more stable. Okay, another difference between static RAM and dynamic RAM is that static RAM is much more faster than dynamic RAM when it comes to accessing of data. So static RAM is much more faster because it's often used in the CPU cache where speed is critical. However, it is more expensive than dynamic RAM. Okay, it is more expensive than dynamic RAM. So dynamic RAM is the most common type of RAM that is used in the computer. Now let's look at the comparison table. Okay, so dynamic RAM consists of number of transistors and capacitors. These are what it's used to store and read data, while static RAM uses flip-flops to hold each bit of memory. Dynamic RAM constantly needs to be refreshed. Static RAM does not need to be refreshed. Dynamic RAM is less expensive than static RAM. It also has higher memory capacity, but static RAM has a faster data access time than dynamic RAM. Also, the CPU memory cache makes use of static RAM. Now for dynamic RAM, the main memory is constituted from dynamic RAM and it consumes less power. Now let's look at ROM, read-only memory. So another type of primary memory is ROM. Now, unlike RAM, ROM is non-volatile, meaning that it keeps data even when the computer shuts is off. Okay, and the main difference is that it cannot be changed, data cannot be changed or written to. It is permanent. You cannot change the data that is stored inside this ROM. So the data that is stored inside this ROM are data that are essential instructions like the BIOS. Okay, so the computer often store data. The memory is used to store data that the computer needs to access when powering up for the first time. Okay, also we say that it is non-volatile, meaning that content are not lost when the computer is powered off. It is a permanent memory, meaning that the content cannot be changed or written to by user, unlike RAM. And the content can only be read only. Now let's look at the table. We can use this table to memorize the difference. Okay, RAM is temporary, ROM permanent. RAM is volatile, ROM non-volatile. RAM can be written to and read from. In ROM, data cannot be altered. RAM is used to store data, files, programs, part of the operating system currently in use. ROM is used to store BIOS and other data needed to start up. And then RAM can be increased in size to improve operational speed of a computer. Now let's look at secondary storage and offline storage. So this secondary storage, they are storage that are non-volatile, meaning that when the computer is shut down, the data is still there. And we said that this storage is not directly addressable by the CPU, meaning that the computer cannot go straight to that storage to obtain data. The data has to be moved to RAM. Okay, and then they are non-volatile. The type of storage can store more data compared to primary memory storage, but data access time is considerably longer than with RAM or ROM. So the computer has to get to RAM before it gets to SSD. So the time it will take to obtain data here is much more longer compared to the time it will take to obtain data from RAM or ROM. So all applications, the operating system, device drivers, and general files are stored on secondary storage devices. Now, secondary and offline storage devices falls into three categories. Okay, magnetic, solid state, and optical storage device. So we're going to look at each one by one. Now, let's look at HDD. So HDD is hard disk drive. Now, this hard disk drive are also used to store data, and we say that it store data in a digital format on a magnetic surface of the disk. So this is the disk and it has a magnetic surface. And we say that the platters can spin about 7,000 times a second, and it consists of electromagnets that are used to read data from or write data to the platter. Now, let's look at the reason why HDD is slow. Now, compared to RAM, obtaining data from HDD is at a very slow rate. Many applications require the read-write head to constantly look for correct blocks of data. This means a large number of head movements. Now, a, a hard disk drive has sector and tracks. Okay, it has sector and tracks, and data are stored in these sectors and tracks. Now, so every time the computer needs to obtain data, the the head has to move. Okay, it has to move a number of times until it obtain that data. So this is why the HDD is slow, and we call this the effect of latency. What does latency mean? It means it is the time it takes for a specific block of data on a data track to rotate around to read write head. Okay, so for the computer to read data from the HDD, the head has to rotate many times until it gets to the block where it needs to obtain data. So this is one of the reasons why the HDD is slow. Now, so over time, the files get fragmented, meaning that through time, the HDD will undergo numerous deletions and editing, which leads to sector becoming increasingly fragmented, resulting in a gradual deterioration of the HDD performance. Now, let me just give you a visual representation of what that means. Okay, so let's just imagine that this is our HDD and these are different sectors. And then we have a data stored here, A, then we have B, C, and then we have, let's say, D, E, F, F. Now, when you're using your computer, you save new files, you delete files. So as you're saving or deleting, for example, I decide to delete A, then this space is left empty. Let's say I decide to delete F, then this space is left empty. So let's say I decide to save a new file or save some data, and I have GG. Now, when the computer needs to read this data GG, okay, it has to go through, because the data are not, they are not stored in a close or in the same place. So the computer has to the head read has to go so many it has to go around so many times until it can obtain this G and G from the HDD. So this is what it means by that this sector leads to fragmentation. So, and then because of that, it takes longer and longer to access data. But in order to help rearrange the data to be stored more efficiently, then defragmentation software can be used to improve on a situation like this by tidying up the disk sector. So by moving the data to, for example, there are two space here, and then let's say there's another space here, and we have B, C, and then we have B. So this can be removed from here and placed here. So that is how the fragmentation works. Now let's look at removable hard disk drive. So these are like regular HDD, okay, but the difference is that they are external. So you need to plug them into your computer via USB ports, and they are very great for backups or transferring large files between computer systems. Next up is solid state drive. So this storage device has no moving parts, and all data is retrieved at the same rate. So how does the SSD store data? Okay, first of all, the data is stored as zeros and ones in a millions of tiny transistors. And the stored data is stored data by controlling the movement of electrons through the logic gates NAND or and NOR gate. So when the electric current reaches the control gate, okay, when the electric current reaches the control gate, and then it flows through to the floating gate, okay, it flows through to the floating gate to be stored. So a dielectric coating separates the two transistors, which allow the floating gate transistor to retain its charge. So this is why the memory is non-volatile. Now, what are the main benefits of solid state technology over hard disk drive? Number one, they are more reliable because they have no moving parts. So for a device that has a moving part, it's much easier for it to get damaged. And then they are lighter when they are lighter in weight compared to HDD. They don't have to get up to speed before they work properly, unlike HDD that has to move, rotate. Also, they have low power consumption. They run much cooler than HDD. And because of no moving parts, they are very thin. Data access is faster than HDD. Now, what is the drawback of SSD? So, because SSD have a limited lifespan, it has a limited lifespan. They are usually rated for a number of write operations per day over several years. And this is what we call SSD endurance. Now, memory sticks, flash memories, also known as pen drives, they use solid state technology. And they are usually connected to the computer through the USB port. Now let's look at CD and DVDs. So CD and DVDs, they are examples of optical storage devices. Now, CD and DVD uses laser light to read and write data to and from the surface of the disk. And both CDs and DVDs use a tiny layer of metal alloy or light sensitive organic dye to store data in the disk. Now, as with HDD, a CD and DVD is also divided into sectors, allowing direct access to data. And data is stored in what we call pits and lands on the spiral track. So it's like this. Okay, so this is pits and this is land. So when a disc spins, the optical head moves to the point where the laser beam contacts, and the disc surfaces and follows the spiral track from the center outward. Now, what are the differences between CD and DVD? So, a DVD has more storage capacity than CD, and also DVD can be dual layered, it can be double layered. Now, a single layer DVD still has more storage capacity compared to a CD. So, meaning that if it is dual layered, then it is like times 2 of the storage capacity. So this is due to the smaller pit size and track width in the disk. Now let's look at Blu-ray disc. So Blu-ray disc is also another example of optical storage medium. However, they are different from DVDs in their construction and in the way they read and write operations. Now, what is the difference between DVD and Blu-ray? So, a Blu-ray disc uses blue laser to read and write data, whereas DVD uses a red laser. And then we said that the wavelength of blue light is 405 nanometer, while DVD red laser is 650 nanometer. Let me give you a visual example. Now imagine we are writing on this space. This is SSD and this is DVD. So imagine you're using a pen and a marker. So you're using a marker to write on DVD and you're using a pen to write on SSD. So the mouth of the DVD of the marker is much more wider when it is writing compared to the mouth of SSD of the pen when it is writing. So because of this, of course, SSD will be able to store more data compared to DVD. So the shorter the wavelength of the laser light, the greater the storage capacity of the medium. Now, Blu-ray disc automatically comes with a secure encryption system that prevents piracy and copy infringement. This is an advantage of using Blu-ray disc. And the data transfer rate for DVD is 10 Mbps, but for Blu-ray disc is 36 Mbps, which means it is much more faster. Then a Blu-ray disc and DVD both can be single layer and double layer. Okay, now let's look at the comparison of the capacity of DVDs and Blu-ray disc. So, a standard dual layer DVD has the storage capacity of 4.7 GB, which is enough to store a 2-hour standard movie, while a single layer Blu-ray disc has a storage capacity of 27 GB, which is enough to store 2 hours or 13 hours of movies. A dual layer of Blu-ray disc has a storage capacity of 50 GB, which is enough to store 4.5 hours of high definition movies or 20 hours of standard movies. Now let's look at virtual memory. So sometimes your computer runs out of RAM. Your computer runs out of RAM, and instead of crashing, it will need to use another type of memory as a virtual memory. Now, one of the problems that is associated with virtual memory is memory management. And this means RAM running out of space. So if the amount of RAM that is available is exceeded due to the multiple programs, due to the multiple programs that the computer needs to perform, then there is high chance that a crash will occur. So in order to solve this problem, HDD or SSD is utilized as the virtual memory if there is need for more memory. So RAM is the physical memory, while virtual memory is RAM plus swap space, which is HDD or SSD. Now let's imagine that we want to run 5 instructions, okay, from 0 to 4, but we only have a 4 available slots in the RAM. Okay, we only have 4 available slots in the RAM. So meaning that there's another instruction that there's no space for in the RAM. Now what happens? To solve this problem, the extra instruction is moved temporarily into the HDD or SSD and is put in a waiting state. So now when the virtual memory now moves the oldest data out of the memory, this one, into the HDD to allow the fourth program to gain access to memory. So meaning that, let's say the computer has executed this instruction, then this memory will now be swapped for the data that is in the waiting state, and then the data can now be moved to RAM. Now let's look at the topic cloud storage. So cloud storage is another method of storing data on remote servers. So instead of storing your data on local disk drive, so this data can be saved in the cloud, and this is accessible via internet. Now there are 3 common systems of cloud storage. We have the public cloud, private cloud, and hybrid cloud. Now, what's the difference between them? So, a public cloud storage is a storage environment where the customer or client and cloud storage providers are different companies. Now, a public cloud is when a third party company provides a cloud storage over the internet, and these services are open to anyone who wants to use or purchase them. So think of company like Google Drive. So this is a cloud storage, and this same cloud storage is provided to different users. It's provided to schools, individuals, companies. Okay, so this storage is not meant specifically or exclusively to one organization. So many organizations are making use of this Google Drive. So that is a public storage. Now, a private cloud storage is a storage provided by a dedicated environment behind a company firewall. Customer, client, and cloud storage providers are integrated and operate as a single entity. Basically, a private cloud storage is used exclusively by one organization. So it is either hosted on premises, solely owned and maintained by that organization. Now, let me give you a picture example. Now, imagine companies like IBM, So this company would provide a private storage that can be controlled and managed by the organization they are providing the storage from. So, for example, IBM can provide storage A for a specific company, let's say Coca-Cola. Then it provides another storage B, let's say for a company Pepsi. So Pepsi does not have access to, is not using the same storage as Coca-Cola. Same thing, Coca-Cola is not using same storage as Pepsi. Unlike Google Drive, where all the organizations are using the same storage, Google Drive. So that is the difference between public and private cloud storage. Now, hybrid storage is basically the combination of the two storage, meaning that an organization can decide to use both public and private storage to store data. So, data that are more private, more sensitive, will be stored in a private cloud, and data that are less sensitive will be stored on a public cloud storage. Now, let's look at the benefits and drawbacks. So, customers can store files stored on the cloud can be accessed anytime from any device. So, wherever you are, you can always have access to your data so far you have your device and internet connection. Also, there's no need for customer to carry external device all around since the data is on the internet. Then the cloud storage providers provides user with remote backup with obvious benefit to alleviate data loss or data coverage. So meaning that if anything goes wrong with that storage, then the cloud storage providers still have a way to recover those data. Now, what are the drawbacks? If the client has a slow or unstable internet connection, then it will be impossible or take having problem with accessing or downloading their data files. Also, cost can be high if the large storage capacity is required. So, for example, like Google Drive, there's a specific storage amount that is given to you. So, when you exceed, then you will need to purchase more. Also, there's potential failure of the cloud storage. And when this cloud storage fails, that means that data can be lost. There's the risk of all the backups being lost. Then more benefits of the cloud storage. So if the customer or client has failure of their hard disk or backup device, then cloud storage will allow recovery of data. Lastly, the cloud storage system offers almost unlimited storage capacity, meaning that if you need to expand your storage capacity, then you can just pay more to get that storage um, upgraded. Okay, so this is all for data storage. Thank you guys so much for watching. Do not forget to like, share, and subscribe.